Welcome back, welcome back, welcome back. In this new video, I will be showing you how to find a centroid for a composite material. In subsequent videos, you're shown how to draw how to find a centroid graphically for rectangular shape object and for a triangular shape object as well. The principle is basically the same, except that we will be treating each section or the figure. We will be breaking down the figure into sections. So here we have a square, and here we have a triangle. To find the centroid for this part first, we simply draw diagonals. So we draw one diagonal from here through to here, one diagonal, and a second diagonal from here through to there. And here is the centroid for this piece, centroid. Now to find a centroid for this piece, again, we are gonna draw a line from the center of this to the adjacent side, one from here to there, or from the center of this side to the adjacent angle. And our next step is to find the centroid from find the midpoint of this side and draw a line from there through to this. I'm gonna bisect the side to get that. So for that, I'm using this. If you're using AutoCAD, what you would do, you would simply engage divide, and you'd use divide to get that. So I'm bisecting this side to get the midpoint, and the midpoint is here. Here is a midpoint. So my next step is to draw a line from this midpoint to the adjacent angle, which is here. Now at the point where both bisectors meet is our center, which is here. So our centroid for that part is here. This is called C1, C2. Now this is the first part. The next step is to combine both centers. It's to draw a line from centroid 1 to centroid 2, then establish a ratio. So I'm gonna join here to there. And the rule states that to find a centroid for a composite shape, we simply find the area. We establish a ratio. We find the area of each side, then break it down into a ratio, and then divide the distance between both centroid into a number, into the ratio, then mark off the smaller portion closer to the larger side. In this case, I went ahead and I did some maths. So the area of A, which is a triangle, is half base times height. In this case, the base is 50, height is 100. So half base times height, half 50 times 100 works out to 2,500. Now for the area of the side, we have 50 by 50, which is length by width. This works out to 50 by 50, which gives us 2,500. So in this case, the ratio is 1:1. What this means is that the centroid is located at the midpoint between these two centroids. So let us measure this distance. this is 50, 57, 57. Or what I could do, the best thing is would be to bisect, to bisect that distance. So I'm gonna use my compass to bisect between this center, and this center. Okay, so I'm gonna use my compass to bisect between center 1 and center 2, center 1 and center. So I open my compass a little bit more than half. Scribe an arc from here to there. Scribe a second arc. Now, if you were using AutoCAD to do this, you would simply draw a line from here to here, then establish the midpoint. And the centroid would be right here. So let me establish a horizontal line here, or a horizontal line here. Or I could use a dimension, as that seems to be, no, yeah, that seems to be parallel. So we could extend this down to the dimension line here. Let me use a different color marker to establish this. So this would have been the centroid. Centroid would have been right here for the composite figure when both centers are combined. Now, the question asks, what would be the distance from the centroid to the right side of this figure? Or what would be the distance from here to here? Let's see what that distance is. It would be 51, 2, 3, 53. So the distance from the centroid to the right side would be 53. And if the question, if you ask, what is the centroid, what is the distance from the centroid to the right side, it would have been, what's that, 95, or yeah, 95 or 96. Yeah, so the distance from the centroid to this end is 53. Yeah, so that is how we draw you find the centroid for a composite shape. Again, the principle is that whenever you're given a composite shape like this, so the x and the y, I need to establish something that the x and the y, xy could have been here, x and xy could have been here, or y could have been here, y could have been here, and x could have been here. Yeah, so this could set up like this. We have y here and x here, and they could ask you to find the centroid from here, from this point. Yeah, or you could also establish the centroid. What the centroid is, the centroid will be located centroid, centroid. So a centroid would essentially be, so this is this is y, this is x. So the centroid from this point would have been here on the x-axis, 95. It will be 95, 95, comma, and this would have been 25, which is half of that. So from here, from origin here, centroid is 95 on the X and 25 on the Y. From this side, you would calculate there. All right. Peace out, guys.